Picture this. 50,000 years ago, you're not the only human on Earth. Not even close. There's you, and there's at least 3 or 4 other kinds of humans walking around at the same time, sharing the same planet, breathing the same air, hunting the same animals. Different bodies, different brains. Some of them way tougher than you. Some of them smarter in ways you're not. Fast forward to today, and there's just one human species left standing. You, just you. Every single other branch of the human family tree is gone. So, what happened to everybody else? Let's start with the basics, because the numbers alone are kind of insane once you actually sit with them. Scientists have found solid evidence of at least 9 different human species that walked this planet at some point. 9. And I want to be clear, that's not 9 tribes of the same species, like different countries today. That's 9 actual, genuinely different species, as different from each other, biologically speaking, as a wolf is from a fox or a horse is from a zebra. Different skeletons, different brain sizes, different survival strategies. And right now, in the year you're watching this, exactly one of them made it. 1 out of at least 9. That is a brutal survival rate. If you were placing bets 50,000 years ago on which human species would still be walking around today, the soft, slow one with no claws, no fur, and no real natural weapons was not the obvious pick. Let's talk about the one that lasted the absolute longest, because, spoiler, it's not us. It's Homo erectus. These guys showed up almost 2 million years ago. 2 million years. For a little perspective, everything humans have ever built, every city, every war, every piece of technology you've ever touched, all of it happened in the last few thousand years. That's a blink compared to what Homo erectus pulled off. They were just out there, existing, generation after generation, for basically forever. They were also the first humans to actually start looking kind of like us. Long legs, built for walking and covering serious ground. They're widely believed to be the first human species to leave Africa entirely and spread out into completely new, unfamiliar territory, which back then was an absolutely massive deal. Their brains were smaller than ours, sure, but they were way, way bigger than anything that came before them. And their tools barely changed for hundreds of thousands of years, which sounds boring, until you realize that's not because they were dumb. It's because what they had already worked so well, there was no real pressure to improve on it. Why fix something that's been working for 500,000 years? So, what actually took down a species that survived for 2 million straight years? Here's the thing. It wasn't dramatic. No massive extinction event, no single disaster. Their last known population ended up stuck on an island in what's now Indonesia. No easy way off. The forests they relied on for food started shrinking around them. Their food sources dried up bit by bit. And slowly, quietly, without any big final moment, they just ran out of chances. The last known Homo erectus fossils are dated to around 110,000 years ago. After outlasting basically everything the planet could throw at them for 2 million years, they were just gone. No headline, no dramatic ending, just an empty island where a species used to be. Now, let's talk about Neanderthals, because honestly, they've been getting slandered for decades, and it's not fair at all. For a long time, popular culture painted them as dumb, grunting, knuckle-dragging cavemen. That image is just flat-out wrong, and the more research comes out, the more wrong it looks. Neanderthals were built like absolute tanks. Thick bones, powerful muscles, wide chests built for strength and heat retention. And here's a fact that surprises most people. Their brains were, on average, slightly bigger than ours. Not smaller, bigger. They hunted massive, dangerous animals up close and personal, which is exactly why their skeletons show injury patterns that look almost identical to modern rodeo riders. Constant impact, constant physical stress. They controlled fire reliably. They crafted genuinely sophisticated tools. And there's solid growing evidence that they buried their dead with actual intention and care, not just tossed bodies aside like garbage. That's not primitive. That's a species capable of ritual, of meaning, of grief. Neanderthals lived across Europe and large parts of Asia for over 300,000 years. Then, around 45,000 years ago, Homo sapiens, that's us, started moving into the exact same regions. For a stretch of time, both species actually lived side by side. And yes, they had kids together. That's not some fringe theory, that's confirmed by DNA. Most people alive on Earth right now carry a small percentage of Neanderthal DNA in their genome. You might be one of them, but living next to us clearly came with problems for them. We were hunting a lot of the same animals. We were competing over a lot of the same land. The difference is, we tended to move in bigger groups with wider social networks that stretched across long distances, trading resources, tools, and knowledge between communities that had never even met each other directly. Neanderthals, on the other hand, tended to live in smaller, more isolated groups, which meant when things went bad, a harsh winter, a bad hunting season, disease, they had a much harder time bouncing back. Add constant, unpredictable climate swings on top of all that, and their numbers just kept shrinking generation after generation. By around 40,000 years ago, they'd vanished from the fossil record entirely, not wiped out in one dramatic event, just slowly, steadily squeezed out of existence. Next up, the Denisovans, and this is honestly one of the wildest stories in the entire field, because we barely have any physical evidence they even existed at all. The entire discovery kicked off with a single tiny finger bone, found deep in a cave in the Altai Mountains of Siberia. That's it. One small bone, small enough to sit in the palm of your hand. Scientists extracted DNA from it, expecting to match it to something already known. Instead, they got a result that matched nothing. Not Neanderthal DNA, not modern human DNA, not anything else on record anywhere. A completely unknown branch of the human family tree, hiding undiscovered this entire time, in one cave, in one mountain range. Since that first discovery, researchers have found almost nothing else physical. A few teeth, a partial jawbone found high on the Tibetan Plateau. That's basically the entire fossil record for an entire species of human. But here's the part that makes this whole thing genuinely mind-bending. Their genetic fingerprint is everywhere, in living people, right now. Populations across parts of Asia and the Pacific Islands carry Denisovan DNA today. Some groups, particularly in Melanesia, carry as much as 6% Denisovan ancestry. And Tibetans specifically inherited a gene from Denisovans called EPAS1 that lets their bodies function normally at extreme high altitudes where most other humans' bodies would start shutting down from lack of oxygen. A species we can barely find physical proof of in the ground is still, quietly, helping people breathe on mountaintops today. That's not ancient history. That's happening in someone's lungs right now. Then there's maybe the strangest chapter in this entire story. In 2003, on a small Indonesian island called Flores, researchers uncovered the remains of a completely different kind of human, something nobody expected to find. These individuals stood only about 3 feet tall. Their brains were roughly the size of a grapefruit. When the discovery first came out, a lot of scientists were skeptical, assuming these were just modern humans with some kind of growth disorder or developmental condition. But as more evidence came in, it became increasingly clear this wasn't a disorder. This was a genuinely separate species, Homo floresiensis. They lived on that island alongside Komodo dragons, giant storks, and miniature dwarf elephants, in this bizarre little ecosystem shaped entirely by island isolation. And that's actually the key to understanding what happened to them biologically. When animal populations get isolated on islands for long enough, evolution does strange, extreme things. Large animals tend to shrink down over generations. Small animals sometimes grow larger. Homo floresiensis might be one of the most extreme, most dramatic examples of this process ever documented in the entire human family. Their fossils date from roughly 100,000 years ago down to maybe 50,000 years ago. And here's the part that stops people in their tracks. Modern humans were arriving in that exact region of the world around that same general window of time. Nobody knows exactly what happened between the two groups when they crossed paths. But here's the thing about small, isolated island populations. You don't need some massive catastrophic event to wipe one out. Sometimes a species just runs out of room, runs out of resources, runs out of time, quietly, without any grand explanation required. So back to the actual question everyone's been waiting for. Why are we the only ones left? The easy, obvious answer is because we're smarter. But that explanation falls apart almost immediately once you actually look at the evidence. Neanderthals were smart, genuinely smart, with bigger brains than ours on average. Denisovans adapted to survive in some of the most extreme environments on Earth. Environments most modern humans still can't handle without serious technology. Homo erectus straight up outlasted us by a massive margin, surviving for nearly 2 million years, while our entire species hasn't even hit a fraction of that yet. And the tiny humans on Flores survived on limited island resources under conditions that would break most people alive today. Being smart, on its own, clearly doesn't fully explain why we're the ones still here. What might actually separate us comes down to something a lot less flashy, a lot less obvious: connection. Homo sapiens didn't just live in small, isolated pockets and hope for the best. We built networks, real networks, stretching across huge distances, connecting totally different communities that might never even meet face to face. We traded tools, ideas, techniques, and survival knowledge across those networks constantly, which meant when one specific group hit a crisis, a famine, a disease outbreak, a natural disaster, their accumulated knowledge didn't just vanish along with them, because that knowledge had already spread somewhere else, to other groups, other regions, other generations. When the climate flipped dramatically and entire regions became genuinely unlivable overnight in evolutionary terms, we had the flexibility to actually adapt and reorganize because we were never fully locked into one single place, one single food source, or one single fixed strategy. But even all of that isn't the complete story, because honestly, luck played a real part in this too. Being in the right place with enough population numbers at exactly the right moment in history. We weren't cosmically destined to be the last human species standing on this entire planet. We just happened to be. That's a genuinely uncomfortable thing to sit with if you think about it for too long. Here's the part of all this that's actually worth sitting with, though. The other human species weren't some rough draft version of us. They weren't failed early attempts, broken prototypes before evolution finally figured it out, and landed on the correct final design. That's not how any of this worked, and it's not how evolution works in general. They were their own complete, fully formed version of what it means to be human, each one figuring out survival in its own unique way, on its own unique terms. Homo erectus made it almost 2 full million years and still eventually ran out of luck on one isolated island. Neanderthals survived brutal repeated ice ages for hundreds of thousands of years and still eventually disappeared from the fossil record entirely. The Denisovans left behind almost no physical trace of themselves whatsoever, and yet their actual DNA is still alive, right now, in real living people walking around today, helping some of them breathe easier at extreme altitudes. For most of human history, stretching back millions of years, you weren't the only human story unfolding on this planet. You were just one single branch on a much, much bigger, much older family tree. A tree with at least 9 known branches. Now, after everything, after every ice age, every isolated island, every climate shift, every disease outbreak, every quiet extinction that happened without a single headline, you're the only branch left standing,